Welcome to my speech called Data Ecosystems Driving Green Transition. And I must say, I think it's great to be here again. And it's great to see that API Days is now having tracks on sustainability. And for the first time, I also get to be on the sustainability track. I have been part of the API Days community for some time now, and now it's great to be able to also talk about this subject, and of course, how that links to data and APIs. And what I'm going to do is I'm going to share some examples of sustainability ecosystems, and my hope is that as a key takeaways from this session, you will have some examples of how ecosystems can be drivers for a green transition. My name is Olli Kilpeläinen, and basically I had the privilege to work on multiple different kind of products, most of them with APIs, ranging from things like smartphones to media devices, cloud services. I had the privilege to dabble on robotics and drones, and then also industrial IoT. So adding API-driven services to manufacturing companies like elevator companies, locking and security companies. And currently, I'm bringing data ecosystems and platform way of thinking to chemistry. I'm going to tell you a bit more about that shortly. But as said, this is now a sustainability track. So of course, it makes sense to start from the United Nations Sustainability Development Goals. You've probably seen this before. So the 17 different goals that cover multiple different angles of sustainability and are super important goals for all of us to think about in our daily work. My examples will cover these four areas. So from industry, innovation, infrastructure, to sustainable cities and communities, to responsible consumption and production, and of course, backed up by the climate action itself. But especially, I'm about to start from production that's related then to the cities and infrastructure. And there, I'm going to start from a material called concrete. I'm sure you have all seen concrete in your day-to-day lives. Why is that relevant? Concrete is actually the second most used substance in the world, right after water. So only water is the one substance that's used more than concrete. So very, very widely used substance. And why you should care is because concrete is also a huge factor in our carbon footprint. Actually, 8% of the global CO2 footprint comes from the concrete. And the biggest part of that is actually the cement in the concrete. That's covering 7% of global CO2 footprint. It's a huge part of our global emission. If you look at that from a wider angle, slightly old statistics, but still very close to reality today as well. So the construction itself, covered by two different parts here, is like 41% of the footprint. 25 going to the operations of the buildings, like day-to-day use, and 16 in the so-called embodied carbon emissions. And in the embodied, the construction phase of the building, the biggest part is the materials and there the cement, 43% of that. What that means is that cement constitutes something like 2.3 gigatons of carbon dioxide emissions every year. That is a huge number. For example, aviation, flying, which is often seen as a big bad thing in the emission space, is way, way smaller than the emissions caused by cement. So clearly, a big, big problem. And a problem, luckily, that we have different solutions for. And what we can use actually APIs, data, and ecosystems to tackle. So let me tell you how. Regular concrete is basically, I'm not going to go to too much detail, but on high level, what you do is you combine gravel and sand with a binding material, something that's sort of the glue in the material, which in this case is usually that cement I've been talking about, and then of course water. And what you get out of is concrete and very high carbon dioxide emissions. Now, the company that I'm working on now, called Betolar, is having a new way of building concrete. What we are actually building is something called geopolymers. And there, instead of using this highly polluting cement, what we try to use is industrial side streams. What this means is basically waste from other industries. We can, for example, work with metal industry, take the ash that comes out of their burning process, or what is called slag that's left over when they have created the metal products that they use. And we can reuse those things that used to be waste and use them to be the glue in the concrete product. And then we add what we call our secret sauce, so-called geoprime activators, which is basically chemistry. So we need to add different kind of chemicals together. And with this mixture, by doing basically circular economy, using someone else's waste and our secret formula, we can generate concrete-like products that have way lower CO2 footprint. Now the challenge, of course, is that now we are starting to look at very different kind of materials. So you need to start understanding what kind of waste is produced by exactly metal or mines. In our case, we work a lot with mining, or forest industry, or even heating solutions where you're burning some kind of substances and producing again ash or other materials that can be recycled. And at the same time, we need to always change what kind of chemicals are used. So it's a complex way of working. And therefore, we have to disrupt the way concrete workers work. So in the past, they used to have people who are really on site. They're trying to make the mix on the fly. How much cement do I need? What kind of gravel do I have today? How much moisture is in the air and in the sand on this particular day? And it's like in the picture now. But what we are trying to do is because we are now changing the process, what we're actually doing is we are adding artificial intelligence. We are adding data. We are adding the possibility to automate a lot of these steps and doing the science in the background. So we are going towards very different way of working, as I've been asking Gen AI to produce the pictures attached. And because we are approaching this from a very different angle, so we are still, of course, we need to get materials from somewhere. There's a lot of logistics involved, of course. We receive samples from different sources, and we need to test the materials. There's multiple different test scenarios and laboratory tests that we are still doing, but we always collect data. That's, of course, the one thing. And then when we start thinking about what kind of chemical formula we are doing, so what kind of chemical research and development we do, we have artificial intelligence, physical modeling attached to the process. And then we have solutions that come out. We make different commercial applications. So also the applications vary a lot based on what kind of buildings you're building, for example, what kind of concrete-like products you're doing. Or are you building, for example, supporting structures in a mine, which is our focus area at the moment. And all the time in this loop, you learn more. And as you can imagine, because this is starting to be a bit more complex cycle, we have to collaborate. So we are also working with external laboratories, for example. We are collaborating with multiple different universities, and we are all in all doing this actually globally. So we have many different actors throughout the world, throughout the value chain. And therefore, what's of course a key to success is to have that data available and share it between the different parties through APIs, of course. And since the solution is really combining those waste streams from other industries, and then of course, whoever is our end customer, whether it's a construction company or a mining company or something else, what we really need to do is combine those two. So combining a company that does produce something we can reuse and the end customer in our case. So what we are trying to do with this AI-empowered solution of ours is to actually be the one who's doing the matchmaking. So we are matchmaking between the side stream owners and those end industry players. And of course, in the same ecosystem, we have to bring those external parties that help us. For example, the labs and universities I mentioned. But there are also other technology providers that are helping with the process, some chemical, some geological, and some software or AI. And of course, there are then standardization bodies and so forth. So really bringing the players together is how we can actually make the impactful change and lower the CO2 emissions in these industries. We couldn't do it alone. One driving requirement why this is becoming such a relevant thing in our industry is life cycle analysis. So in Finland, it's becoming now mandatory in 2025 for built environment, meaning all the buildings out there, to calculate the full life cycle impact that any product in the building has on the environment. And that means that you need to start tracking a lot of different things. For example, what are the raw materials? What is the CO2 footprint there? How do you transport them? Of course, taking materials from one place to another adds to the emissions quite a bit. What kind of manufacturing processes you have, and so forth. And this life cycle analysis, hence, is a good example of how you really need to start sharing data between different companies. And it's, of course, has always been a bit of a challenge that you have multiple different parties working together. Every site can be different, referring to construction sites. So it has been very difficult to calculate the full footprint. But now, because it is legislated and you have to do it, luckily we are seeing a lot more improvement in this area. And we are also, as a company, of course, working on that. But really, data, APIs, clear set of rules is needed. Now, I mentioned in the beginning that I also want to share other examples. So this was, in a nutshell, what my current company is doing. But there's, of course, a lot of different actors in this space. And I want to share some other examples of ecosystems that are trying to bring the sustainability aspect closer to reality through data and APIs. And here's one good example. This is by KiraHub in Finland. So it's a hub for any kind of built environment solutions. And they have an ecosystem called CO2 Data Hub, which nowadays is, I think, almost 30 companies working together. And they're exactly also trying to make sure that the calculation of the emission footprint is clearer and something that's transparent, and you can work together with the different parties, driven by the same needs as I just mentioned. So here again, it's super important that this ecosystem is working together to define how you report your numbers, how you calculate the CO2 footprint in your product, how you transfer that data to the next one in the value chain, because again, it's not good enough if you have only one aspect of the value chain, but you really have to check each and every point on the way to get the full truth out there. So hence this ecosystem is trying to define APIs, set of guidelines, data formats, and so forth, because trust is crucial here. You have to make sure that we can trust the calculations that others give, and that's why standards and common ways of working are so important. Here's another example. So in addition to calculating the emission footprint, another very important part of sustainability is biodiversity. So for example, if you are building a new factory or simply a accommodation house, basically you have to check what kind of nature is there. So what are you doing to impact the biodiversity in the area where you're building? And here's another good example. It's a startup called Aila from Finland that I had the privilege to follow. And what they are building is basically an automated, proper science-based calculation methods for calculating both the emission data and the biodiversity data. So that different parties can again basically utilize the same way of calculating, making sure that it's guaranteed to be correct, it's trustworthy data, and then be able to share that to different parties. And these kind of ecosystem players, these kind of solutions are really needed in order for us to go forward with our sustainability actions. Here's another interesting example from Finland again, but this is from the Finnish Environmental Institute. They have something called Siirto Register, and this is actually a register related to waste removal. So meaning moving different kinds of waste from one place to another, to a landfill or somewhere else to be recycled. And basically when they started this program, what they identified is that the different companies had actually built over 20 different softwares for just handling the documentation. And I'm referring to documentation about what kind of waste you're transporting, from where, to where, what kind of safety aspects there are. Over 20 different softwares. So what they tried to do with this program is basically to build one common solution through APIs that allow you to handle the document, so that not every company has to make their own solution anymore. And they are handling both digital documents and also digitalizing of the paper documents that might still be out there. So very good initiative, hopefully lowering the cost of the different companies, making it easier to collaborate. The unfortunate side is because it is a public project, at least at the moment, the APIs are not open for private sector. So at the moment, it's only intended for the public sector there to be able to support and help. But I'm hoping that in the future, these kind of initiatives also allow private parties to add their value-added services here and make it even easier for the companies to drive the sustainability actions. Another example, I already mentioned that my current employer is also working with ash, but ash is actually something, ash from different burning processes, can be anything from waste to metal to forestry and so forth. It's actually a very complex value chain. But the ash being produced from the different incinerating processes can actually already be used for multiple different applications and purposes. For example, fertilizing fields, ground construction, forestry, road basing, road covering, fields, walls, so forth. So there's multiple different applications with different requirements. And of course, in order to use that, you need to figure out what are the potential legislative things, are there any hazardous things in the waste, you need to handle the logistics, which can be very complicated and so forth. So Forest Center of Finland has been trying to build this kind of conceptual ecosystem for ash, where they are handling everything from the analyses, the product certifications, bookkeeping, quality checks, logistics, and so forth together, again, in order to make it easier. And naturally, what this is dependent on is that the different companies in the value chain would actually share their data. They would open up APIs, they would let others see the data they are producing. Very good example of trying to get very traditional industry working together and where really data sharing is the key. Then one more example on a European scope. So you might have heard about the European Data Spaces initiative, that they are building multiple of these data spaces. But one particularly interesting related to this area that I'm talking about is the Green Deal data space. So this is basically trying to bring the green aspects together with data economy in order to drive circular economy, biodiversity, pollution, climate change adaptation, and so forth forward. So what they're trying to do in these European data space initiatives is to get again different industries together, and this is now European scale, so even more and bigger ecosystems. But what they want to define is common data structures, common data models, technical interfaces and technical tools, maybe even develop new standards together with the technical or legal, and also helping with the contractual things. And of course, building the so-called IT structure, so regular software components. So I think very good initiative. And I think if we are able to help EU push through these kind of initiatives, that could be very helpful for everyone. Sometimes they can be a bit slow, but if we try to help and interact with the different companies, this could be another driver for a very positive change. So I now shared a number of different examples, and as you have heard, the value chains are very complex. There are different kind of companies doing different kind of things around materials and emissions and biodiversity. And some of them maybe already have APIs. Many of them do not, and they're trying to bring out data sharing. So how do we find all this data? And then when they are in different format and they're a bit difficult to combine, how do we combine the data and get to proper results? Maybe AI is actually something that can help us here. So for example, I'm now trying with my team to experiment with AI agents. This can be used, of course, to discover APIs, so trying to find out what kind of APIs are out there, hopefully do the effective data transfers, for example, and data format changes, so we can actually reuse sources from different places and so forth, and of course do analysis and optimizing of the results as well. So perhaps AI would be another way for us to make this change faster and speed it up throughout these traditional industries. Would love to hear more about that, by the way, if someone is listening to this and would like to share some examples. But to wrap it up, basically the sustainability is a common goal of all of us. It is no longer something that can be done as a side thought, but sustainability has to be there in all the actions we do, and luckily it's also becoming a business enabler. So really it has to be a common goal. And I firmly believe that APIs, data, and ecosystems can be forces for impactful positive change. So working on these technologies that most of you who are watching these API Days recordings love can really make a positive change. Thank you for listening. I hope you got away some examples that may resonate for you. Many of my examples were touching the sustainability goals I mentioned in the beginning, but you have very similar challenges in other parts of the different sustainability areas. And I do believe that many of them really need those data sharing activities, the common agreed criteria, what kind of data you have, how you share it, how you collaborate, and let us all work together.